In this video, I want to talk about the bistable circuit. So the bistable circuit is the fundamental building block for other state elements. So it is important that you pay attention to how bistable circuit is working. So bistable circuit consists of two inverters that are connected back to back. So we have I2 here. Its output is serving as the input to the other inverter, I1, and then the output of I1 is serving as the input to the first inverter. So as you can see, it can form a loop. So for the bistable circuit, we consider to have two outputs. We call this one Q bar and this one Q. And this thing can be shown in a different configuration as well. So not necessarily anything changes in terms of the connections, but the way that it is being represented in this form, it is much better. So as you can see here, we still have the first inverter I1. Its output is creating Q, and then that output is connected as the input to I2, which creates Q bar, and the output of I2 serves as the input for I1. So as you can see, we don't have any inputs for this circuit. So now, since we don't have any inputs for this circuit, how can we analyze it? So to analyze it, we can assume the outputs to be at some value. So since we are working with binary numbers, the outputs are either 0 or 1. So let's just see what happens when we have, for example, for the first case, we have Q to be 0, right? So something happened in the circuit and now Q is 0. So even though we don't know what is the input, there are only two possible cases for the value for Q. It's either 0 or 1. So let's just assume we have Q to be 0. So we want to see if this state is a valid and stable state. So if Q is 0, does it remain at 0 or not? So we have Q to be 0. The same Q is being delivered to I2 as input. So that means that the output of I2 or Q bar is going to be the complement of 0, which is 1. So basically we followed this path from Q to the input of I2, and then we created Q bar. So now for Q bar we have the value 1. So this 1 is basically being delivered to I1 as the input. So now the input of I1 is 1, which makes its output to be 0. So you see, we started with 0, and then we followed the path, and we ended up at 0 for value. I ended up at 0 for the value of Q. So as you can see, if Q is 0, no matter what was the condition that made Q 0, Q remains at 0. So that's why we say that the state is consistent or stable, because if Q is 0, it remains at 0. Let's just go over the other case. For the second case, we assume Q is 1. Again, since there is no input, we don't know how Q became 1, but we just assume it is 1 now. So when Q is 1, that means that the input to I2 is 1, which makes its output to be 0. So Q bar becomes 0. Now we have Q bar serving as the input for I1, which makes the output of I1 to be 1. So when you have 0 at the input of this inverter, its output is going to be 1. So the same thing happened as before. So when Q is 1, following the path of the signal, we see that Q remains at 1. So that means that this state is also stable and consistent. So as you can see here, this unit can be used to save or store 1 bit of state, or it has 1 bit of memory. So if we assume Q is our memory, when it's 0 it remains at 0, when it's 1 it remains at 1, right? So it doesn't change its value over time. But there is an issue here. Because we don't have any inputs to our circuit, it is very hard to control it. So we don't have any saying on what value is being saved here, because we don't provide any input. So for whatever reason, maybe some noise, this Q becomes 0 and then it stays at 0. Or it becomes 1 and then it stays at 1, right? So the important thing for us is to have some control over what we need to be storing in our state element. So that is the main limitation for the bistable circuit. Even though it is able to store 1 bit of state, since there is no input, it is not very common in practice. But as I said before, the bistable circuit is the fundamental building block for making state elements. So in the next video you will see how we modify the design of the bistable circuit to create a circuit that we can actually control using inputs.